In Unit 3, we talk about trigonometric ratios, indirect measurement, proportionality, and we'll also lead into periodic functions, step and piecewise functions. In this video, we're going to talk about those first three things: trigonometric applications, indirect measurement, and proportionality. Whenever we discuss trigonometric applications, we're going to be talking about the sine, cosine, and tangent ratios all within a right triangle. You typically are used to hearing SOHCAHTOA. We'll also discuss the law of sines and cosines whenever we're discussing triangles that are not right triangles, basically anything else. And then also finding area of triangles. There's a trigonometric application and a formula that allows you to find the area of a triangle using sine, cosine, or tangent. When discussing the sine, cosine, and tangent ratios within a right triangle, it's going to be very helpful to make sure you use language that is easily understood by the student, and you can nice and easily draw a picture to reference that language. So I always like to first identify whichever angle is being referenced in that triangle using theta. You can also use whatever letter you want to. However, the key to labeling and understanding these right triangles is making sure you know which side is opposite. Which side is opposite of that angle. And language such as it's the side that does not create that angle, it's a side, the only side that's not adjacent to that angle is the opposite side. And of course, they should all know what the hypotenuse is of the right triangle, which leaves only one more leg, and that leg is the adjacent leg to angle theta. And then of course you should know the sine, cosine, tangent ratios from SOHCAHTOA. Sine is equal to the measure of the opposite side divided by the measure of the hypotenuse. Cosine is the measure of the adjacent side divided by the measure of the hypotenuse. And then tangent is the measure of the opposite side divided by the adjacent side. Problems that are going to help you apply this and make sure the students know how to do this very well, especially in real world type of application, are angle of elevation, angle of depression problems. Also, students can pretty well use this in terms of indirect measurement as well, and we'll get to that. Students can also use this in terms of indirect measurement, and in just a few minutes we will show. Students can also use this in terms of indirect measurement, and in just a few seconds you will see how indirect measurement and trig ratios can be applied together. The law of sines and cosines, we first want to make sure the students know how to properly label the triangle, any triangle that they're given. Capital letters represent the angles, lowercase letters represent the side. This is also a good way of being able to identify sides opposite in order to try to help reinforce the trig ratios discussion. The side opposite the angle has the exact same letter. Of course, it's lowercase because sides are represented with lowercase letters. And then we have the law of sines formula. We have sine of angle A divided by side A is equal to sine of angle B divided by side B is equal to sine of angle C divided by side C. This tells us the transitive property here. It says sine of A over A is equal to sine of C over C because they're both equal to sine B over B. So you can rewrite it however you need to. Here we have the law of cosines where we have A squared equals B squared plus C squared minus 2BC times cosine A. There are three different ways we can write this formula, and as long as you memorize one way to write it, you can repeat the process for the other two sides. It's very simple. So instead of solving for A squared, I want to solve for B squared. And since I've replaced A with B, I got to do that all the way across the formula. I got to replace B with A, B replaced with an A, and then this A here is going to be replaced with a B. And now I have the second way to write this formula, and then I can do the exact same thing writing the third formula. And then the last trigonometric application we have is area. We're trying to find area of a triangle that's not a right triangle, and we don't know the altitude. If you know the altitude, then you have the triangle area formula is 1/2 base times height. But here we don't have the altitude, and it's going to be fairly difficult to calculate. So we have all these pieces of information, but we want to find area. Well, we have this formula that comes from we have this formula here. We have area is equal to 1/2 B times C times sine of A. And if you want to write that in terms of some kind of layman's terms, to where if you don't have the triangle labeled, you can always use the formula. You have area is equal to 1/2 of the first side that's given to you times the second side that's given to you times sine of the angle between. Sine of the angle between those two sides that were just given to you, which is this information right here. We have B and C, and then this right here is the angle that is between B and C. 1/2 side 1 times side 2 times sine of the angle between those two sides. And that will calculate the area for you, and it will also allow you, regardless of the angle or the sides given to you, it'll allow you to calculate the area of that triangle. Next, we have proportionality. Proportionality, the two basic ways to incorporate proportionality is to talk about unit conversions, which we should have done quite a bit of this in the Fermi question assignment, maybe even the tennis ball assignment. You might have even done it in the crowd estimation assignment, where you're having to convert feet to inches or to miles, etc. Also, similar figures. Similar figures allow you to calculate some distances or measurements from one figure to another, as long as you know that they're similar. We did this with the aspect ratios in the media. So we were trying to find the constant of proportionality. If you were told the aspect ratio of 4:3, you could find the width and the height of a similar triangle with a diagonal or hypotenuse of 25. Well, here we know that x is equal to 5. And so we can find the width and the height by taking the constant of proportionality times 4 and then times 3. So this here is 4 times k, and this is 3 times k. So this is how we use similar figures and ratios in the media. Unit conversions, pretty simple here. If we want to convert inches to millimeters, 1 inch is the same as 25.4 millimeters. And so in the changing tires problem, we talked about the millimeters of the width. So let's say that's 325 millimeter width. What is the conversion of that into inches, so we can then calculate the height into inches? So proportionality has been addressed in several of the other videos and other assignments. For indirect measurement, we can find the height of objects based on similar figures. So in this case, this is your pretty standard example for indirect measurement. We want to find the height of this flagpole. Based on the shadow cast by the sun here, my shadow here, or the shadow of the person, is 8 feet long. This person is 5 feet tall. And then we can also see that the measurement along the ground here is 27 feet, the shadow for the flagpole. So we have where we can set up a proportion. We have 8 to 27 is equal to 5 over x. And then we can find the cross products and then calculate the value of x. Be 16.875 feet. This allows us to indirectly measure the height of this telephone pole.